Hi, this is Mrs. Young, and today we are in the second half of our circles unit, and we're going to be talking about actually an algebra concept. So we're going to be talking about completing the square. Last year, Mrs. Hoekstra did teach you completing the square. It was a method that you used for solving quadratic equations. Maybe instead of quadratic formula or factoring, there's something called completing the square. So today's kind of a review of an algebra concept that we use in geometry. When the equation of a circle is written in what we call standard form, and they give you an example, it's easy to graph it because we can easily determine the radius and the center. So like when I look at this equation right here, that's the equation of a circle, I know that the center is -3, +1, and I know that my radius is the square root of 14. So we know that because it's in that standard form of the equation of a circle. The equation's not always going to be in that form though, so sometimes we have to get it into that form. So like here's an example of an equation that's not in standard form, right? That's like a general form, just a crazy form. I don't even like that. So when we give you the equation in this general form, we need to use completing the square to get it into the standard form. And the reason we like the standard form is because then we can see the center and the radius, and then it's easy to graph also. So again, reviewing this concept of completing the square. Perfect squares such as x plus 3 squared follow a pattern. So again, think back to algebra with Mrs. Hoekstra, right? If you have x plus 3, the quantity squared, that means you're taking x plus 3 times x plus 3. I like to call it FOIL, or some people call it just double distribution. X times x is x squared. X times 3, that's, oops, sorry, I didn't mean to put another plus sign. That's 3x. Then when I multiply the 3 times x, that's 3x, and then the 3 times 3, that's 9. You know to combine your like terms in the middle, so you get x squared plus 6x plus 9. So that's really just FOIL or distribution, right? So when we distribute this or multiply it out, we get x squared plus 6x plus 9. We want to try to create a perfect square here. So if I took that middle term, my b value, which is 6, and cut it in half and then square it, that would give me a perfect square trinomial. 6 cut in half is 3, right? And 3 squared is 9. So that's considered a perfect square trinomial, right? Looking at the relationship between that b value and c value, we can tell just by looking at that trinomial that it's a perfect square trinomial. Again, because the b value cut in half squared is the c value, right? And that's kind of what they're talking about over here, if you want to kind of read that over. So one thing that we noticed in our perfect square trinomials is that the c value, right, the constant, the number by itself, was equal to b over 2, the quantity squared, if it was a perfect square trinomial, right? That was that relationship or pattern we saw in perfect square trinomials. Oh gosh, and I know I forgot to mention this at the beginning of my video. There's 3 pages here, so hopefully you printed them out of Google Classroom. I know they're in the packet also, but I also just wanted to separately post them today. If for some reason you're not printing that out, you might want to be copying some of this down as I go through this. It says from this pattern, we're able to recognize trinomials that are perfect squares because 1/2 of the linear term, that's your b term, is squared, is the constant term, and then they're saying when a is equal to 1. So again, notice that the coefficient on the x squared, right, that's just 1. So these are what I call the easier trinomials because I don't have an a value or a coefficient in front of the squared term. So down here it says, determine if the following are perfect squares or not. So if I look at that first one, right, my b value is 2. Well, 2 cut in half is 1, and 1 squared is 1. Does that equal this c value? No. So that is not a perfect square trinomial. Looking at b in the middle. Again, my b value is 6. 6 cut in half is 3. 3 squared is 9. So that middle term cut in half squared is the last term. So yes, this is a perfect square trinomial. If I wanted to factor that would be x plus 3, the quantity squared. In letter C, is this a perfect square trinomial? Again, look at your b value, 4. 4 divided by 2 is 2. 2 squared is 4. So yes, this is a perfect square trinomial. Again, this would factor into x plus 2, the quantity squared. That last one here, again, my b value, the middle term, we've got -8. -8 cut in half is -4. -4 squared is a positive 16, and this is a negative 16. So absolutely not. That is not a perfect square trinomial. In fact, a perfect square trinomial will never have a negative c value because you can never square something and get a negative value. It says, let's look at the completing the square process. What value would form a perfect square for? So in their first example, they have x squared plus 8x plus blank. Half of 8 is 4. 4 squared is 16. So then the number that they're wanting to plug in here, the magic number is 16. And that would factor into x plus 4, the quantity squared. In letter B, my b value is -2. Half of -2 is -1. -1 squared is 1. So the magic number we're plugging in there is 1. So this would factor into x minus 1, the quantity squared. We're trying to find the number that would create a perfect square trinomial. In letter C, we have 5. Half of 5 is 5 halves, and 5 halves squared, well, 5 times 5 is 25. 2 times 2 is 4. So the magic number that we'd be plugging in here is 25/4. Again, this would factor into x plus 5 halves, the quantity squared. I know that we don't always like fractions, but sometimes we do have to deal with them in the completing the square process. So now I'd like you to go ahead and just pause the video and see if you can figure out what to plug in for the magic number to create a perfect square trinomial. So pause the video and try these 4. Okay, so completing the square is something that you learned last year. Hopefully you're recognizing some patterns here. In A, 12 cut in half is 6. 6 squared is 36. So 6 is the magic number I'm plugging in, which would give me the squared binomial x plus 6, the quantity squared. In letter B, -6 cut in half is -3. -3 squared is 9. So I get x minus 3, the quantity squared. Letter C, 9 cut in half, 9 halves. If I square that, 9 squared is 81, 2 squared is 4, so 81/4 is the value I'm plugging in. So that would be x plus 9 halves, the quantity squared. And then the last one, -20 cut in half is -10, -10 squared is 100, so this would be x minus 10, the quantity squared. Again, yes, you may occasionally have fractions here. You need to leave those as fractions or in fraction form. Let's go ahead and turn to the next page. Again, I think there's 3 pages that we're going to go through here. On the second page up here at the top, you know what? I decided to skip this top section because they're talking about expressions, and I really wanted to deal with the equation. So I'm skipping the top half of the second page, and we're going to go down to completing the square process as an equation. So they're giving us an equation here. X squared plus 8x minus 3 equals 0. So the first thing you want to do is move your constant over to the other side, right? And then we also notice this is not a perfect square. 8 divided by 2 is 4. 4 squared is 16. That's not the right constant value. That's why we kind of push that 3 to the other side. What they're doing here is they're adding or plussing the 3 over to the other side just to get it out of the way. Then we put little blanks in here because we're trying to figure out what is going to be the magic number that we can add in here to create a perfect square trinomial. If we add something to one side of an equation, we have to add the same thing to the other side to keep it a balanced equation. So here's where we take that b value. 8 divided by 2 is 4. 4 squared is 16. So we're plugging in our magic number of 16. If I'm adding 16 to the left side, I have to add 16 to the right side. Now we have a trinomial on the left side. That's a perfect square trinomial, right? This is going to factor into, if you want to do the long way, right? This is going to be x plus 4 times x plus 4, which is x plus 4, the quantity squared. Me and you, are going to leave it like this. I know they say to move it back over. We're not going to do that. We're going to leave this on the other side for our circles problems. So we can stop right there. Let's go ahead. I'm going to do the first example here with you. Again, is this a perfect square trinomial? 2 cut in half is 1. 1 squared is 1. That's not the correct value. So I'm going to push this to the other side. As I move that 13 over, I'm also going to insert blanks here because I need to plug something in to create this perfect square trinomial. So again, my first step was to move that constant over. Now I'm going to figure out what I'm plugging in. Again, we're using that little formula, b over 2, the quantity squared, right? 2 divided by 2 is 1, 1 squared is 1. So I'm adding 1 to both sides of my equation. Now that left side is factorable, right? This is x plus 1, the quantity squared. Negative 13 plus 1 is negative 12. So there's my expression where I'm done completing the square. So I would like you guys to try B and C, completing the square on that quadratic form. Okay, so the problem in the middle, they had already moved the constant over. B is 10. 10 divided by 2 is 5. 5 squared is 25. So that's the number I'm going to add to both sides of my equation. I have then created a perfect square trinomial on the left side that I can factor into x plus 5, the quantity squared. In letter C, I had to move my constant over, so I subtract the 2 over. Negative 8 cut in half is negative 4. Negative 4 squared is 16, so I'm adding 16 to both sides. Again, remember, anytime you square something, it's a positive value that you're adding in. So we get x minus 4, the quantity squared, equals 19. Again, notice when your b value is negative, there's a minus sign here. But if your b value is positive, there's a plus sign here. That's hopefully a pattern that you noticed back when you were in algebra completing the square. So let's turn over to the third page here of our completing the square process. Why am I doing this? Why is Mrs. Young doing all this completing the square from algebra? Because this will help us get our equations into standard form, our circle equations. We want them in standard form so that we can, in turn, graph them, right? If we saw a circle equation like this, we have no idea what it looks like. That's ugly. We want it in standard form because then I can tell what my center is. Like the center's negative 3, 1, or my radius is the square root of 14, right? So that's our whole goal here, is to get it into standard form. That's why we're doing this. So here, knowing this pattern is going to help us change circles into general form, into standard form. Again, that's what we want, standard form. In standard form, we can determine the center and the radius easily, and that'll help us when we go to graph them. Here's an example. We're going to walk you through the process step by step. Again, remember, in a circle equation, you're going to have some x terms and some y terms, right? That's that standard form of the circle. Oh, again, if you don't remember, it's x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. That was the standard form of the equation of a circle that we talked about yesterday. So in an equation of a circle, you're actually going to have to complete the square twice. You have to complete the square for the x terms and the y terms. So that's why they're inserting a blank here and here. Again, they also should have put little blanks on the other side too, right? Again, we're going to start with our b value, 14. 14 divided by 2 is 7. 7 squared is 49. If I add 49 to the left side, I should be adding 49 to the right side. Similarly, with my y values, my b value here is negative 8. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Again, if I'm adding 16 to the left side, I should also be adding it to the right side. You want to keep your balanced equation, your equation balanced. So then we can have the x trinomial factors into x plus 7, the quantity squared, perfect square trinomial. And then the y terms factor into y minus 4, the quantity squared. Now we have this in the standard form of a circle. I know by just looking at that equation that the center of that circle is negative 7, 4, and that the radius is 8. So there's a whole purpose why we're completing the square. In my next example, it says, first we notice the equation is not in standard form. We want to make it a standard form circle. They have already put the constant over here on the other side, so they complete the square on the x values, right? So my b value here is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. Again, if I add 1 to this side, I should add 1 to the other side. So this creates a perfect square trinomial with your x's, which is x minus 1, the quantity squared. Notice, and this one's a little bit different or unique, there is no y term. There's a y squared term, but no y term. So that means that the y coordinate of the center must be 0, right? So I didn't have to worry about completing the square on those y values. Just a little bit easier. So now I can see that my center is at 1, 0, and then my radius is the square root of 9, which is 3. Let's try one down below here. Again, they kind of set it up for me. I guess I do have to add the 8 over, right? So I'm going to rewrite this x squared plus 4x plus blank. I got to complete the square here, plus y squared minus 2y, sorry, minus 2y, oh, my problem, plus blank. And then I'm going to add the 8 over equals 8. So now I have to figure out what I'm going to fill in the blanks, because then I'm going to have to add those same values to the other side. So looking at your first b value, 4 divided by 2 is 2. 2 squared is 4. So I'm adding 4 here, which means I'm going to add 4 over here. With my y terms, my b value here is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I'm going to add 1 to both sides. So now as I factor this, again, the x values are going to factor into x plus 2, the quantity squared. Again, 2 times 2 is 4. 2x plus 2x is 4x. And then for my y terms, this trinomial is going to factor into y. Whoops, I almost put a plus sign, right? But again, I noticed this is a minus sign, so it's y minus 1, the quantity squared. Again, negative 1 times negative 1 would give you a positive 1. But then a minus 1y and then a minus 1y will give you the negative 2y. And then over on the right side, 8 plus 4 is 12 plus 1 is 13. So now we know that we have a circle centered at negative 2, 1, and the radius is the square root of 13. So I would like you guys to try letter B right next door. Complete the square on the x's and then on the y's, adding what you need to on the other side, and get this into the standard form of the equation of a circle. So try letter B for me right now. Okay, so for my x terms, I added in 16 to complete the square. For my y terms, I added in 25 to complete the square. So I have x minus 4, the quantity squared, plus y plus 5, the quantity squared, equals, add these all up, I got 31. So this is called the standard form of the equation of the circle. And we know just by looking at it that it has a center at 4, negative 5 and a radius of the square root of 31. So in tonight's homework, you're going to be practicing this process of completing the square. If you're still really struggling with completing the square, you can go back to maybe like Khan Academy and watch some videos. I'll even post an additional maybe 10-minute video on completing the square if you're really struggling. I know it is something that you did learn in 7th grade in algebra though, so you should have some background knowledge on that. Your homework for tonight, let me see, I have a picture here somewhere. Your homework for tonight is going to be just practicing completing the square. There'll be an example here. This is what the worksheet looks like. There's an example, and then let's see, 1, 2, 3, 4, 5, 6, 7 problems on that page. And then the next page, again, there's an example. Look at fractions, right? It's okay, you can do fractions. And there's 1, 2, 3, 4 problems there. I did want to mention these last 2 problems. They're a little bit different. What is different here is that there is a number in front of the squared term. So what you need to do first, I don't know if you can tell this, but they divided everything by 3. That was a GCF, or greatest common factor, of all of those terms. So first they divided everything by 3, and the numbers came more manageable, right? So divide out that GCF. Just like here, you're probably going to divide out a GCF of maybe 7 or 6 to make the numbers more manageable. Because when we're doing completing the square here, we want to have the a value as 1. Notice these all have an a value of 1. I'm just checking. Yes. So again, that's your homework for tonight. There are 11 problems total on completing the square. Good luck and have a good day. Bye, guys.